Hi everybody, it's Mrs. Pound and I'm back. We're moving right along through our second chapter on linear motion and we're moving right into acceleration. So our objective for today is to define acceleration and give examples of units for acceleration. So you'll find this in section 2.4 of your book. Acceleration is the rate at which velocity changes with time. So it's another one of those rates that I said we were going to talk about. In the previous section, we talked about speed and velocity. With acceleration, when you are in a car and it accelerates, it is the change in motion that you feel. That change that you feel, that is acceleration. So the equation for acceleration is acceleration equals the change in velocity over change in time. Or writing it in symbols, A equals delta V over delta T. And remember, we use velocity and speed pretty interchangeably, except the only difference is velocity has direction. So because we're using velocity with acceleration, this is another one of those vectors. Acceleration has magnitude and direction. Units for acceleration, the SI unit is meters per second squared, but another unit you might see is kilometer per hour per second. So what three controls change the acceleration of a car? Well, what ones change the velocity of a car? The gas pedal, because it sped it up. The brake, because it slowed it down. And the steering wheel, because it changed direction. It's the same thing with acceleration. The same thing, three things that change velocity change acceleration. When you have a change in velocity or a change in direction, you have a change in acceleration. So if I'm driving on the highway with cruise on and drive around a curve, I am accelerating because I am changing direction. I don't have to change my speed, or I just have to change my direction. I can change both, or one or the other. So let's take a look at a problem with acceleration. So here I have, what is the acceleration of a car that goes from 0 to 100 kilometers per hour in 10 seconds? Now you will see this problem on each slide. You don't have to rewrite it or anything. I just have it there so you can see the numbers to see what I'm plugging in on each slide. So we start always by writing down our equation. A equals delta V over delta T. We substitute in the numbers. And here, I always put my second velocity first and my initial velocity second. So final minus initial. And same with the time. So I put 100 kilometers per hour minus 0 kilometers per hour over 10 seconds minus 0 seconds. So that simplifies to simply 100 kilometers per hour over 10 seconds. And when we divide 100 by 10, we get 10, and then for our units, kilometers per hour per second is how we write that. So let's take a look at another example. What is the acceleration of a car that goes from 0 to 10 meters per second in 1 second? So again, I start with my equation always. Then I plug in my numbers. I put my final velocity minus my initial velocity, which is 10 meters per second minus 0 meters per second, over my final time minus my initial time, which is 1 second minus 0 seconds. When I simplify, I get acceleration equals 10 meters per second over 1 second. When I divide that, I get acceleration equals 10 meters per second per second. Or another way to write that and simplify that, the best way to write it is 10 meters per second squared. So this is it for this video. We covered for our objective defining acceleration and giving examples of units for acceleration, and we even did a problem. Now remember, 5 questions in that margin, and I'll be back with more next time. We'll talk about acceleration due to gravity. free fall.